Ready to learn all about lists in Python? Let's go. Welcome to Chyld Studios. In today's video, I'm going to be talking about the Python 3 list data structure. The objectives for this video are I'm going to define what a list is, show you how to create a list manually, show you how to create a list using the range data type, show you how to add and remove items from a list using append and pop, how to get the length of a list, how to perform some aggregate statistics such as sum, min, max of a list, how to access different elements in a list, how to loop over it, how to zip up multiple lists and work with that, and then finally how to do list comprehension. I'm going to start off with I'm going to be using my terminal. Now I'm currently using Python version 3.6. And I've installed it using Anaconda. There's multiple ways of installing Python, but I've used Anaconda, and you can just look up Anaconda on the internet, or you can just go to the Python website and they have a download for Python. So I'm using Python 3.6, and I'm going to be using IPython, this REPL. That's a read eval print loop. That's just what this thing is called here with this prompt. I'm going to be using that to sort of go over today's lesson. So here we are. We're in Python 3.6, this REPL here, and let's get started. So I'm going to go ahead and start off and create a list. I'm going to call this thing L1, and I'm going to put some elements in there like 7, 8, and 9. And here's my list. Now what I can do first of all to verify this thing is a list is I can say type of L1 and it says it's a list. Now a question you may have is what is a list? It's just an order, it's a collection of ordered elements. So 7, 8, and 9 are in a specific order. So anytime you enumerate or iterate or try and access this list, these things 7, 8, and 9 will be in that order. So if you have a bunch of things and you want them in a particular order, a list is a really good data structure for that. So I have, like I said, I have this L1. It's a list of 3 things, and I created it manually. Now there's another way of creating a list, and that's using range. So I can create that using I'm gonna create a variable called L2, and I'm gonna say range. And how range works is you can give it a starting point and an ending point, let's say 25. Now if I did that, it says range 10 to 20. What you have to do is when you use the range, you have to actually convert it to a list by wrapping it in the list constructor. So now if I say L2, here's my list. So you can either create, there's multiple ways of creating a list. Up here, this is one way manually. Another way is I can create a list using the range data type. So when I did a range from 10 to 25, it actually gives me a list it creates a list from 10 to 24. It actually doesn't include 25. It's not exclusive. It doesn't include that number. So here's I have this list, L1, L1, and then L2. L1 was created manually, L2 was created using the range data type. So here's different ways of creating a list. Now, once you have a list, a good thing that you might want to know how to do is how to add something on to the end of it. So I can take this L1 and I can append. Let's say I want to append the number 11 onto the end of this list. There it is. I could do it again. Put 13 on. Put 13 on there, and there it is. So append lets you append some element, some item on the end of the list, not the beginning, not the middle, not anywhere in between, but it has to be append puts it at the end of your list. Now, once you have something at the end of your list, or once you've added something, you typically want to pull something off. Or I shouldn't say typically, but sometimes you'll want to pull something off from the end of the list. If I do L1.pop, The result here was 13. 13 was actually the end of this list. So when I said pop, it actually removed the thing that was on the end. Um, and I can verify that by typing in L1, and you can see that now there's only 4 items in the list, whereas before there were 5. So it actually removes it. Now you could capture that into a variable. I could say 11 equals L1.pop. L1 now has 3 numbers in it, but the variable 11 actually has the number 11 in it. So this allows us to not only pull off an item off the end of the list, but capture it into this variable right here. So once again, append allows you to add something to the end of a list. Pop allows you to pull something off from the end of the list. Okay. So I have L1 here. Here it is. Now, what if I want to do some aggregate statistics? Well, the first thing maybe before I show you that is, how would you know what the length of this list is? So I can say type in len. It's a function in Python, and you put in some list, and it'll tell you how many things are in there. So it says L1, there's 3 things in it. L2, there were 15 things in it. So if you want to know how many things are in your list, just use len, and it will give you the length. Now, if you want to do some aggregate statistics, let's say, here's my L2. What if I wanted to sum up all these items in this array? Like, how could you do it? Well, there's a top-level function in Python called sum. Pass it a list, and it will basically loop over or enumerate or iterate through all these items and keep a running total, and then 255 is your total. What if you wanted to know what the minimum value was in L2? It'll tell you. Or what if you want to know what the max value was in L2? It was 24. Now, what if you want to know what the average was? Now, there's no top-level element or function called average. See that? But what you could do is you could say, give me the sum of L2 divided by the length of L2, and that takes sums them up and then divides by the length, and so that of course is the formula for average. So that's just so you can't type in AVG, that doesn't exist, but just by doing this is a very simple, quick way also of finding the average. Okay, so that's length, max, min, sum, and of course our own little average function that we just did. The next thing I want to do is talk about how to access different elements in your list. So here's my L2. Let's say I want to access the first item in the list. Now, just like normal arrays or lists in other programming languages, lists start out at index 0 is the first element. So if I put 0 in here, I'm going to access this first element. And then 24 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it looks like it's 14 and 24. So that's great. Now what happens if I type in an element that's not there? Well, I'm going to get an error. It says you get a list index out of range. And that's correct because this index is out of range. It really only goes from 0 to 14. But you notice how I just counted up to 14? That was pretty easy to count, but what if there were like a million items in this array? You're not going to be like counting, to the end. Now, what you could do is you could take the length of L2 and say, well, there's 15 of them, and then you would take the length of L2 minus 1. And of course, that'll get you the last element. But Python actually has a pretty interesting way of accessing elements at the end, and that's by using negative indexing. So I can type in -1 like this. So here's L2 again. -1 actually counts backwards. So 0, this is 0, this is 1, this is 2, this is 3, etc. But I can go 3, 2, 1, 0, -1, -2, -3, -4, etc. So you can count forward using positive indexes, or you can count backwards using negative indexes. So the -1, so 0 is the beginning of the array, and then -1 is the end of the array. So there's another thing you can do is you could actually specify a start. Let's say I wanted to go from 11 to 14. I wanted the items from 11 to 14. Well, 11 is index 1, and then I can use this colon operator here, and I can grab 14. So 14 is actually index 0, 1, 2, 3, 4. See, that's 4 right there. That's index 4. So I can put 4, and we'll see what happens. Well, this looks close, right? There's 11, there's 12, there's 13, but it actually didn't give me the 14. What you need to do is you need to actually give it one index higher than what you want. So if I want the 14, I would type in 5. And it gives me 11, 12, 13, and 14. 15 is actually the fifth index, 0, 1, 2, 3, 4, 5. But it actually, when you use this syntax here, it actually doesn't give you this index, it gives you one before it. So yeah, so this is pretty interesting. What if you wanted to go from from index 1 to the end of the list? Well, if you just put a colon, then it goes from 1, here's 11, to 24 to the end of the list. Now, what if you wanted to go to from index 1, or let's go from index 2 to the end of the list? Great. But what if you wanted to pull out all the even values? Well, what you'd like to do is you'd like to skip every other one, and so this last one, the first argument is the start index. The second one is the end index, which it doesn't actually include. It's one before it. And then this last one is the stride or the step amount. So this says started index 2, which is here it is, 0, 1, 2. So it's going to start at 12. 2. So it's going to start at 12. And then there's nothing here. That means go to the end of the list. So that means go to 24, and this last one says :2. So that means step every other one. So it's going to go 12, it's going to skip 13, and go to 14. It's going to skip 15 and go to 16. So the start, stop, and then the stride or the step allows you a lot of flexibility in accessing different elements in the array. Now I could take this thing and let's say I want to know the sum of the even values between 12 and 24. Well, using that, I can kind of just put all this stuff together, and there it is. There's 126. So that's how you access different elements in an array. The next thing I want to do is talk about looping over a list. So here's my, let's see here, what's an L1? Here's my L1. What if I wanted to loop over it? So you would say for item in L1. Now, this syntax that I just wrote here, the for is required, the in is required, this L1, that's the name of the list. This item, that's the individual item that's going to get pulled out of L1. So L1 has three values, 3 elements, 7, 8, 9. So the 7 will go into item, then 8, and then 9, just like that. But you don't have to call this item. I could have called it dog or cat or X or Y or whatever, but because it is an item, I'm gonna call it that. But this is you can call this really whatever you want. So if I say print like that, and so there it is. It printed out the item. It printed out the 7, and then the 8, and then the 9. Now, what if you wanted to, I don't know, add 3 to each value? Well, I could just take this item here, and I can just say +3, just like that. And then there it is. It went from 7, 8, 9 now to 10, 11, 12. So once you have this variable item, you can kind of just do whatever you want to with it. You could take the square root of it to the 0.5 power, and there it is. Now I've taken the square root of item. So that's pretty interesting. Now what if I wanted to get the index as well too? Not only item, but also its index. Well, how you do that is I'll put IDX for index. Now this is just a temporary variable, just like this is a temporary variable. Um, uh, yeah, so you can call this thing X, this one Y, this one dog, this one cat. You can call these things whatever you want, but this does represent the index, so I'm going to call it IDX, and this represents the item. So how you do this is you have to say enumerate. It's a top level Python function, and what that does is it returns a tuple of two things. So the first item in your tuple, this is kind of like destructuring. It kind of pulls that tuple apart. The first item in the tuple goes into index, and the second item in the tuple goes into item. So I can take that, and then I can say, let's see here. Let's do a dash and a 1 like that. And I can, let's see here. I'll put the index first, IDX. So I'll put the index first. The index will show up first, and then the square root will show up second. So yeah, so you can see 0 is index. Here's the square root of that value that was in index 0. Here's index 1 and its square root at that value, and then here's index 2 and its square root. Once again, if you forget what L1 is, it's 7, 8, and 9. So 2 is the square root of 7. The square root of 7 is 2. Square root of 8 is 2.82, and the square root of 9, of course, is 3. Yeah, so this is how you can get the index from a list. Now, most of the time, or some of the time, you may not care what the index is. If you don't care, then you just remove the enumerate. But if you do want the index, then obviously add this, and then add this as well. And that's that. Second to last thing is I want to talk about zip. So L1 is this thing. Let's say L2 is 2, 3, and 4. I'm just going to make these things the same size. So there's L1, here's L2. Let me do that one more time. L1, L2. Great. What if I wanted to put these two things together, these two lists together? Well, there's a function called zip, and this function is lazy, which means it actually doesn't give you the output from. It doesn't actually evaluate the zipping of L1 and L2. It actually, in order to force it to evaluate, you have to wrap it in this list constructor like this, and then it will. So what this is doing, it's called zip because it's like zipping up a zipper. And so you have these two arrays, L1 and L2, and the 2 and the 7 are getting zipped up, and then the 3 and the 8 are getting zipped up, and then the 9 and the 4 are getting zipped up. And you can see, here's the first, from the first index, here's the second index, here's a third index from both arrays. So this is pretty interesting. And how you can use this thing is you could say for x, y in zip L1, L2. So what this is going to do is going to zip up these two arrays, and then it's going to give you a tuple, and it will destructure the tuple just like the enumerate did earlier and pull out the first value. 7 will go here, and then 2 will go here. Let's print this out. Format. Let's say I wanted to multiply x and y together. So I could say x times y, like that. So yeah, 14 is 7 times 2, 24 is 8 times 3, and then 36 is 9 times 4. So anytime you have an array and you want to, two arrays, and you want to mash them together or zip them up, the zip is a good function for doing that. So that's zipping. The last thing I want to talk about is list comprehension. So here's my list L1. What if I wanted to create another list that had the squares of each one of these values, like 49, 64, and 81. So what if I wanted to take these values and create another list with their squares? Now, in Python, just like in other languages, there's a concept of map, which transforms one array into another array. You could do a map. There's actually an easier way in Python, and even though Python does have the map functionality, There's actually an easier way using list comprehension. So how list comprehension works is you use the brackets just like a normal list, except this is what you do. I'm going to put an underscore right here for right now. I'm going to come back to it. And I'm going to say for something in, let's do L1. So L1 is my list that has 7, 8, 9 in it. And what I'd like to do is I'd like to pull out each value one at a time. And so what you can do is you can just call this thing whatever you want, dog or cat or whatever. I'm going to call this thing maybe item, just like I did before. So what's going to happen here is this is your list. The 7 will come in here first, then the 8, and then the 9. Great. Now once you have this temporary variable here, item, what can you do with it? Well, I could just type it here like this. So basically this doesn't do anything. I mean it runs, but visually it doesn't do anything different than L1. So it takes L1, pulls out the 7 right here, and then prints the 7, or puts the 7 in a new list. And then it takes the 8, puts the 8 right here, pulls the 8 out of here, puts it right here, and then it puts the 8 in the list. Then it pulls out the 9, puts 9 right here, and then puts 9 in the list, and then it prints out this new list. So this list, actually, 7, 8, 9, is actually a different list than this one. They're actually different. But this doesn't actually do anything very useful. But what you could do instead is you could say to the second power, right? So now you have the original list L1, and then you have this list, here's your original list, and you have this new list that has 49, 64, 81. Or you can make another list that has, just like I did before, the square root. 2.64, 2.82, and then 3. So that's how list comprehension works. You just take your list, you have your temporary variable here, and then right here is what you want to do with that variable. Maybe you want to square it, maybe you want to multiply it times something else. There's one more thing that's kind of interesting, is you can add an if condition, and you could say if item, let's say I want item to be odd. If item, and I'm going to say mod 2 equals 1. So if I take any number, right, and I divide it by 2, and I look at the remainder, if the remainder is 1, it's odd. So this should actually give me all the odd values, and it did. So 2.64 is the square root of 7, and 3 is the square root of 9. So this is actually the 7 value, and this is the 9 value. So what this did was it kind of looped over all the items in the array, and took the square root of it, but only where the item was odd. So it's a lot of information kind of packed into a very nice compact syntax. So I tend to like these list comprehensions a lot. They're very powerful, very compact, allows you to like express a lot of meaning in not very much code. So anyway, that's it. That's my video on lists and list comprehensions and accessing variables and append and pop and summing and min and max and all these things. Anyway, I hope you liked it, and I'll be doing more videos on Python and also some videos on data science. So stay tuned. Thank you.